So after much deviation from Node.js itself, we're back and raring to go. Before we start, I must mention here that one of the ongoing goals for this course is to cover a lot of technologies and ecosystem workflows that work alongside Node.js. And this would mean that we have to deviate at times from the subject of the course itself to cover other subjects that go hand in hand with the project. One instance being the use of Python in this section and installing Apache Apollo, which might seem to go against the title of this course, all about Node.js. But as with every technology and framework, there are a lot of auxiliary technologies and workflows that you must learn before you can deploy an app in a production environment. And hence, supplementary workflows are equally important in my opinion. Okay, so after this long disclaimer, let's begin. We'll be building our Happy.js app within this folder called Node, where we already have our public and views folder containing our style sheet and our HTML page. On my command prompt, I'm already in the Node folder within the cards printer_begin project folder, and as always, I'll begin by typing npm init on the prompt to set up my package.json file. The more recent versions of npm forbid the use of uppercase characters when typing out the name of the app. So I'm going to call this app cards printer in all lowercase, and let's leave everything else as defaults. Next, let's begin by installing the Happy.js framework. I'll type npm install happy, that's HAPI, @ 10.0.0 followed by ~save. This will download the 10.0.0 version of the Happy framework as used in this project. Now let's begin by creating a HelloHapi example first. I'll also use this example to talk about a few elementary ES6 features. Create an app.js file as always, and I'll begin by typing use strict within single quotes followed by a semicolon. The use strict expression ensures that bad coding practices such as undeclared variables, accidental use of reserved keywords, and basically any coding practice that results in inefficient and insecure code is strictly prohibited by the JavaScript compiler. This expression should be placed on the first line of your script to enable this restricted version of JavaScript across the script in the file. If you place this expression within a function, for instance, then it's only applicable within the function scope. So it's best to enable script-wide strict mode by placing this on the very first line of your script. And here's an important bit. Without the use strict expression, you won't be able to use a lot of ES6 features within Node.js. This is at the time of this recording and may change in the future. However, it is best to have this expression for added security and optimal coding. Next, I'll type const happy, that's happy with an uppercase H, is equal to require happy to bring in the happy module within our app. Now, we just wrote this statement. Before I draw your attention to the const keyword, notice that we used our regular CommonJS require statement to bring the happy module in. If you've been reading about ES6, then you would probably be wondering why I didn't use the native ES6 modules and the import statement that was standardized recently. First of all, at this point in time, Node version 4 only supports ES6 modules using the ~harmony_modules flag, as it is an in-progress feature and the implementation is quite incomplete and possibly broken. So while you can use ES6 modules even today, prefer avoiding them as is. Also, they are semantically different from how CommonJS works, and there are some issues like, for instance, the loading order of modules is not guaranteed.
unlike CommonJS. Therefore, at this point in time, I'm choosing to opt out of ES6 modules, and I would prefer to wait for this to become a natively enabled feature so that we have full clarity on how Node implements it. You're free to experiment though, and I would love to hear about your experiences with the import statement.
The next thing that you saw was the use of the const keyword. This is new in ES6 and it lets you declare a constant identifier that is read-only and cannot be reassigned. Here the identifier happy is read-only and is a constant. Since here we are importing a module, we would never need to use the word happy as an identifier or variable in the app. Hence, it's safer and secure to declare it as a constant by using the const keyword. Here I'm in the Node.js REPL and I'll begin by enabling the strict mode like so. Next, I'll declare a constant called pi and I'll set it to its standard value of 3.1412. Now I'll try and reassign pi's value to 20. Note how there is no error on the console. But note how the value of pi has not changed. So even if the JavaScript compiler fails silently, the actual value is secure and won't be reassigned. Next, I'm going to create a variable using the standard var keyword and I'll try and use pi to assign an arbitrary value of 120. It seemingly works, but again you can see that once a constant is declared, it cannot be reused in the program and our pi still points to 3.1412. So hopefully both the const keyword and the reason why we are still using CommonJS is clear now. Moving on, we'll begin by creating an instance of a server within Hapi like so. The server forms the central core of a Hapi app and everything else binds to it, including routes, modules, and functionality. So every Hapi app begins at its core by declaring a new server. Next, we'll use Hapi's connection method to declare an object where we can set the host and port on which the app is going to work. I'll leave out the host property and it'll default to localhost. However, you can set it specifically to work on a given host name or an IP address. We are only using the port property here and we are setting it to use the port value as is available within the deployment environment through the process.env.port statement, or if that is not available, then default to port 3000. Now it's time to write a route handler and we can do this by using Hapi's route method, which accepts an object where we begin by defining the HTTP verb first to which this route should serve, followed by the path on which this route handler would be invoked. Here I want this handler to serve when the user accesses the app using the base URL or the root. Finally, we'll write a handler function that will actually do what we need to do when a user accesses this route. I'm using the brand new ES6 fat arrow function to declare an anonymous function here that takes in two arguments, a request and a reply. These are quite similar to the request and response that we have seen in the Express framework. The fat arrow or the arrow figure formed by combining an equal to and a greater than sign is used to declare an anonymous function. Note that we are not using the keyword function here. If your function takes in a single argument, you can even leave out the brackets and it would still work. If you wish to learn more about the fat arrow function, I've built a small example that you can watch on YouTube using the link provided in the description of this video. And I would encourage you to do so for a deeper understanding on the arrow function notation. Alright, within the handler function, we'll access the reply property to send back an h1 tag with the words HelloHapi. Now, to start our server, we'll invoke the start method on the server instance like so, where like all previous examples and frameworks, we'll pass in an anonymous function, only this time using an arrow function, and we'll just use console.log to output the string happy server running at followed by using the server.info.uri, which is Hapi's built-in property that gives you a full URL to your app, including the host and the port as set using the server.connection method. Alright, back on the prompt, type node app.js and our Hapi server happily fires up on port 3000. Notice how I get my machine's host name here. And the result of this is a big HelloHapi in our browser.